Hey everyone, today we're going to be doing a short lesson on square roots of non-perfect squares. So there's going to be many fractions and decimals that are going to not result in a perfect square, which means that they can't be written as a product of two equal fractions like we did earlier in the previous lesson. There are two strategies to estimate the square root of a decimal that is not a perfect square. We're going to be looking at using benchmarks and also looking at using a calculator. Now, of course, using a calculator is going to be the easiest method, but we're going to be looking at using benchmarks to look at getting an estimate and doing a guess and check so that we're getting an approximation on what it should be. If we take a look at this first one here, we have root 7. Now, going by the first part of using a benchmark and with a guess and check, we want to look at the ones that are going to be the closest to root 7 that we know are a perfect square. If we also look back to the very first page of the booklet where we have all these listed, you can go back and check there if you can't remember them off the top of your head. But do remember, you have to have these memorized, so all the ones on that first page memorized. But because it's only the second lesson, if you're still not there yet and you don't have them memorized, please refer back to that first page. So root 7, we want to know what it falls in between. Well, root 7 falls in between root 4, which is a perfect square, and root 9, which is also a perfect square. So it falls in between root 4 and root 9. That'll give us an approximation on what it should be. So we have 2 and 3, which they both equal. So we know that root 7 is going to fall in between 2 and 3. Now, the easiest way is going to be our calculator. If we put root 7 into the calculator, we're going to find that it's 2.6, which supports our guess and check that it's going to fall in between 2 and 3. For example, B, we have a fraction of 8 over 5 to a root. So we want to find the root of 8 over 5. Now, we want to find the one that is going to be closest to 8 and the one that is going to be closest to 5. So unlike the one that we did above where it was just to the root of 7, this time we have it set up where we have 8 over 5. So we want to find the closest one to 8, which is going to be root 9 over root, and the closest one to 5 would be 4, which means that 9 equals 3 over 4 equals 2. If we do 3 divided by 2, we get 1.5. So our approximation for what our answer should be around 1.5. If we put it into the calculator of root 8 over 5, we get an answer of 1.26. So we're not too far off from where 1.5 would be. Now, reminder, this is just an estimate. We're using our best judgment in this situation. For 3, I'm going to leave for you to complete. The last problem that we'll go through today is going to be root 0.4, or as it should be written is root 0.4. The first thing that we want to do is turn this into a number that we're able to work with. Now, if we multiply this by 100, it allows us to look at root 40 instead of root 0.4. This gives us options for looking at what could be above and below this root. So below would be root 36, and above would be root 49. Now if we look at this here, root 36 gives us 6, and root 49 gives us 7. so we know our answer has to fall in between 6 and 7. If we were to do this on the calculator, we'd have root 40 equals 6.3, root 0.4 equals 0.63. Now, if we notice, our answers for root 36 and root 49 gave us whole numbers, not decimal places. The reason for that is because what we did is we multiplied it by 100, meaning we had root 100 on the bottom, just like that second option we talked about the other day, which means you have 6.3 over 10. 6.3 divided by 10 gives me 0.63, which would be the answer we're looking for. That'll bring us to the close for this lesson. If you have any questions, make sure you ask me in class, and complete the following questions on your own and check the OneNote for the answers. Have a good day.